Hello my friends and welcome to the Cisco online training and learning for the basic network engineers from CCNA to CCIE. Today, first of all, we're going to study about the layer 2 ARP and the MAC addressing. First of all, this is the basic understanding for the basic concept, because into the real network, if you don't know the basic networking, like what is a layer 2 ARP, what is a MAC address, because I've in my life and experience, I've gone through many network engineers where they know a lot of things but they don't know about the basic networking. So first of all, basic questions to all of the network engineers out there listening to me, whether they are network engineers, whether they are starting with the CCNA, whether they are certified professionals. The first basic thing, whether it's an interview, whether it's for an engineer, like what is a network? Okay, a network is a collection of devices. A network is a collection of devices connected with each other through some media. That media can be either a cable, or it can be either a WAN technology or LAN technology, and communicating with each other through some protocol. What is a protocol now? In every particular definition, there is a different definition. A protocol is a set of rules that allow the communications to happen. Ladies and gentlemen, in front of me right now, there is a basic GNS3 project. Now I'm going to do a demonstration of the layer 2 ARP and the MAC addresses. This is the basic thing many network engineers normally skip, this basic understanding and this basic connectivity. I have nothing configured right now in my GNS3 project. It's a clear project because I want to show you if you are using at home the switches or the routers for the basic demonstration, for the basic understanding, because like nobody have nowadays a lot of time to go out and to buy the real implementation, the original products and all that. If you have this facility at home, sitting down at one place, having a laptop in front of you with everything that you can practice, you can understand the logically, the diagrams and all that, this is something which you can do best. Yeah, it's a reality, it's a fact that GNS3 does not have 100% implementation relating to switching. But I tell you one thing, what I did for my preparation was only GNS3, and you can do approximately 70% stuff on GNS3. And if you do that particular 70% stuff on GNS3 in a better way, in a clear way, you can also do all these technologies, which is must for required and all that. Right now, it's just a clear topology. I'm gonna just add a bit of routers, I'm gonna add a bit of switches, and I'm gonna demonstrate layer 2 ARP and how switch basically learn the MAC addresses and how the communication gonna happen. We go step by step to provide the better explanations, and hope so this video gonna show you the differentiation with this video and other videos that you see on particular topic and all that. So this is the start of the video, and this is a very, very important topic. So my dear friends, first of all, I'm going to show you now that I'm going to add some bit routers and all that. Okay, right now I just want to explain you a bit thing like what I want to demonstrate to you. I want to demonstrate to you two important technologies. The first technology is ARP, the second technology is MAC. Now before demonstrating, before starting, I want to just give you a basic understanding so you guys have made up your mind, like when I just try to draw the topology and do the configuration and all that particular stuff, you should know like what's going on. Yeah, I will go step-by-step process as I try to explain. I will not leave any of the steps aside. First of all, you want to know like what is an ARP request? What is the significance of an ARP request? Why you need an ARP request? What is a layer 2 ARP? What is MAC address table? Yeah, it is a media access control address or burned address or whatever you guys learn from the books and all that. Like how a switch basically store this particular MAC address, and what is the basic significance of this particular MAC address, and how the communication happen from one end of the network to the another end of the network, how our broadcast packets gonna be made and all that. My friends, ARP. The basic purpose of ARP, it's a layer 2 technology, normally in a layer 2 network. As I go through some of the topics or explanations might be you're unable to understand, but note it down as I try to go through the topology, as I try to go through that particular configuration, you're gonna get it useful. So I'm just gonna go with the basic like what's an ARP and what is MAC. Then I go through the configurations, and then you can know a step-by-step process. Now first of all, what's an ARP? Normally an ARP is a layer 2 technology. The basic purpose of an ARP is like every particular end host, every particular PC has particular an IP address and a MAC address. Suppose an PC A wants to communicate to PC B, and they both are on a layer 2 network. Now layer 2 network means they are on the same broadcast domain. They are on the same VLAN segment. For example, host A has an IP address 10.1.2.1 with a subnet mask of \24, and similarly host B has 10.1.2.2 and the \24, which is subnet mask. They are in the same broadcast domain because they have the same subnet mask and they're the same IP address range. Now, if they want to communicate with each other, they can't communicate with this particular layer 3 addresses. An IP address is normally a layer 3 address. So if they want to communicate with each other, they have to use, if they are connected via the media is a switch, it's an Ethernet media, they have to communicate. The communication is via MAC address. So first of all, a switch A does not know like he wants to communicate to switch B. He will send an ARP request to switch B to learn the MAC address of switch that host B. Once you learn the MAC address of host B, then they're able to communicate with each other. This is the basic purpose of ARP. I know many of guys is unable to understand or they're a bit confused what I told, but once I go through the particular topology, I will try to explain this particular concept. You're gonna know the clear picture. A MAC address. Now, between every two hosts or two routers, there's a switch which is placed in between them. The switch basically stores like MAC addresses. For example, if a host number A is sending an ARP to learn the MAC address, the switch basically gonna learn the MAC address of that particular host. Similarly, they are communicating with each other. The switch stores the MAC address like a router. It stores routing table. If there is something wants to communicate to another network, the switch gonna make a lookup into the routing table to have that route in the network. Similarly, switch gonna make a basic lookup on MAC addresses. So this is the basic information, and this is the basic understanding that I want to explain in the first place. So guys, without any delay, let's get started with the basic understanding and the basic connectivity, like how basically layer 2 ARP and MAC addresses work. So first of all, actually my topology is like I'll be having like 3 hosts. These hosts will be the same VLANs and they want to communicate in the network. Now in the GNS3, it's a very bit difficult to demonstrate a host and all that, so I'm gonna make that routers to work like it's a host. Okay, so I have this particular router. I'm gonna take one router here. This is router A. Suppose our host A, we can say that. I'm gonna take another host A, and similarly I'm gonna take third host. Perfect. Similarly, in GNS3, if you want to demonstrate a switching, like how so it's basically gonna learn a MAC address, you can take a C3700 and then you can add basically NMES16SW, which is basically a module in that particular switch. So I'm gonna add this here. After that, in YouTube, you have to go to R4 here, the slots. In the slot number 1, there is one module which is NM16ESW. This module is very important if you want to demonstrate a particular switch to be used as a switch, as total switch. A GNS3 router is being using as a switch. Similarly, router 1, router 2, and router number 3. I'm gonna right click, I'm gonna configure. Nothing I have to do, I just need to add some sort of ports into it and all that. Just a single port is enough for demonstration. Here we go. Perfect. Next, I'm just allow a connectivity between them. So this is, we have the switch. So fast Ethernet 0 by 0 is going to router 1 fast 0 by 0. Fast 0 by 1 is going to router number 2 fast Ethernet 0 by 0. And finally, fast Ethernet 1 by 0 is going to router number 3 fast Ethernet 0 by 0. Okay, perfect. No worries and all that. Let me add like what are the ports and all that added. So this is the first of all the basic things and the basic connectivity which we have. The next step, what we have to do now is we can start this particular devices. It's router number 1 is starting right now. It's router number 2 is starting right now, and it's router number 3 and also the switch number router number 4, which is being simulated as a switch, nothing else. Perfect. So the next thing which I want to do right now, okay, is to go through all of the routers and do the basic configurations. I'm gonna write down here for switch number 1, the port I'm gonna be using this particular IP address 10.1.2.1. This is the subnet mask. They're on the same network, like router number 2 10.1.2.2 /24, and seriously switch number 3 10.1.2.3 /24. Okay dear, so this is, we have end host. This is not, this is host A, this is host B, this is host C, and this is router number 4. You can just, I can just simulating like router 4 is being used as switch, and these are basically end host ones to communicate into each other. I'm going to show you like how they are going to communicate with each other, how the switch is going to learn MAC addresses, and how the basic ARP address is going to help, that how the ARP address resolution is going to work. The next thing I want to show you, like I'm just gonna get and connect to console now. So I'm gonna connect console to all the devices. We have 4 devices, so you can have security or to demonstrate, but right now we have only 4 devices, so I can go to device by device and just can demonstrate. So first of all, on router number 1, so very easy. Just you have to go first of all the basic networking, configure terminal. I want to change the host name. I want to say like this is basically my PC1. Okay, and then basically I want to configure the I want to demonstrate it's a PC, so I want to say no IP routing first of all, and I want to give the interface faster than 0 by 0, and I want to give the IP address, which is 10.1.2.1.255.255.255.0. no shutdown. Exit. Perfect, no worries, nothing else. Similar configuration on PC number 2. I'm gonna scroll it on the side so that I want to show you a basic like connectivity, like how they're connected. Okay, so here router number 2 here. So configure terminal, host name, this is my PC-2, and then I want to give the basic IP address interface faster than 0 by 0, no shutdown. IP address 10.1.2.2.255.255.255.0. exit, and then no IP routing. I'm not using these routers as routing, it's only just being demonstrated for the PCs. Let me go to host router number 3, and let me scroll it on the side so that you have the basic view of the basic topology, like how it's working. Configure terminal, same configuration, interface fast number 0 by 0, no shutdown. The IP address 10.1.2.3.255.255.255.0. exit, and then no IP routing, and then you, for beautifulness, you can change the host name to PC_3. Perfect. We have our PC simulated. We have just the basic, like suppose you have a PC having a LAN card, okay, and just you connect it to a switch if you want to communicate with each other. Now we will go to the most interesting part, router number 4, which is not a router actually, it's a switch, being simulated as a switch and all that. And here we're getting some commands here. So by default, these ports which are connected to a switch, they are by default in half duplex mode. So because I want to show you something here, show run interface fast number 0 by 0. So it's half duplex, so I want to change the duplex to full, because switch by default is using full duplex in GNS3. And speed, no need of speed, it's already using that particular thing. Let me get to PC number 2, and I'm gonna do the basic thing, and in interface fast number 0 by 0, and the duplex is full, just perfect. And similarly on router on PC3, configure terminal, interface faster than 0 by 0, and the duplex is full, and here we go, exit. Perfect. So now we can go to the switch and do the basic connectivity. Okay, so we're gonna go to router number 4, which is not a router actually, it's a switch for us. So I'm gonna change the host name, it's gonna switch. Okay, and then we have the basic connectivity and all that. So first of all, in the basic switching, you have basically 2 types of ports. There is a trunk port and there is a Nexus port. Okay, we will discuss about our trunk ports and what is the basic significance, what's the difference. But in this particular video, I want to demonstrate only the layer 2 ARP and MAC. So any port, just for easiness, any port which is going to an end host, okay, it's an access port. Okay, so it's very easy. Interface fast number 0 by 0, no shutdown. Switch port, interface fast number 0 by 0, and first of all we want to define one VLAN. Let's suppose in switch, and basically the GNS3 switch, we have only VLAN database. Okay, so in this VLAN database we have to define a VLAN. Suppose all the 3 end hosts are in the VLAN, suppose 1 to 3, nothing else. Exit the process. You can see these VLANs are decorated with show VLAN switch commands, and here we are, VLAN 1 to 3. then I'm gonna say like interface fast number 0 by 0, no shutdown, IP routing. Let me check what's the problem with the switch. No IP route, duplex sorter and all that, that's okay, but the switch is not using for routing actually. I want to change it to interface 40 by 0. Check one thing, I want to check the version here. So what I'm gonna do, I'm just gonna add basically these port as part of a Nexus port, because I just explained before like the basic purpose of a Nexus port, like when any end host is connected on a switch is a part of a Nexus port. Okay, and these all particular end hosts will be in a single VLAN. They will be in the same broadcast domain. Okay, so first of all, it's very easy. You can go to the interface fast and one by one. First of all, it is not used for IP routing, and the next thing is interface fast and one by one, no shutdown. And you can say switch port mode access. This is the first command in order to make the port as an access port where when host is connected. Switch port access VLAN 3. This port is in my VLAN 3. They are telling VLAN 3 does not exist because I have not created VLAN, so the VLAN has to be created. I have created VLAN 1, 2, 3. So this is the VLAN I created. So we go to show run interface fastnet one by one. So this is the command we created. Switch port access VLAN 1, 2, 3. You don't have to do anything. There is no problem. Just you have to go again. Next step is you have to go to interface fastnet 1 by 2. Switch port mode access. No shutdown. Switch port access VLAN 1 to 3. They're in the same VLAN. They're in the same broadcast domain. They're in the same IP address range. That's why all these ports in the same broadcast domain. So interface fastnet 1 by 3. No shutdown. Switch port access VLAN 1, 2, 3. And you first of all you can give this access command and then basically switch port access VLAN 1, 2, 3. Perfect. So show interface status. Oh my goodness. Show interface status. We'll show you the port which are connected and which are in the upstate. So here we show you now. So the show interface status showing you like basically you have 3 ports here. Okay, here you have port number 1 by 1, 1 by 2, 1 by 3. Okay, and all these ports are in this particular status. I don't know why they are showing at show interface, show IP interface brief. Okay, so all the ports 1 by 1, 1 by 2, and 1 by 3, their line protocol is showing as down. Okay, so I don't know why they're being shown as down. No shutdown. This is strange thing. Show interface brief. So we have to go to these ports. Like the protocol is still down. I don't know why these are showing as down. Let me get back to router number 1. The host number 1 normally. And showing us up. But why the heck the switch ports are showing us down? and I'm gonna just present a basic connectivity, the lines so guys, we have let me connect the line just we can see from this router the switch number 4 basically we have, so I can change and also the line number 1. So we can see like we did nothing, we just now we can see there is basically a topology here, and we can see like here we have host A, host 1, host 2, and host 3. So again, the configuration wise, it's a very easy configuration. The first basic purpose that you have to elect one thing which is known as the interface first and one by one, which is basically a reference point. So just next VLAN number 3 show run interface first and 1 by 2. So this is all for me. Thank you so much for watching this first and 1 by 2. Okay, dear, and if I go to the basic host we have, so thank you so much for viewing it. Hope so. It has PC1 for you. So even PC1, if I want to see the configuration of the port going towards the switch, just the basic configurations like there is an IP address and show IP interface brief. Show IP interface brief. I want to see the status. It's up. Similarly, on host 2, I can do the basic configuration command. Show IP interface brief, and the host is up. Similarly, we have host C, okay, where you can see in the bottom right, okay, show IP interface brief. This is the command where you can see this is basically up. Now, which we want to allow the communication between them, and now I'm going to teach you the concept of an ARP request and what is basically a MAC address. So, step by step, first of all, you should know what is basically a network. Then you basically take the network elements, plug into each other, then you allow the configuration, and then there is basically a layer 2 connectivity. What does a layer 2 means? Like layer 2 means like when you have a basic network, when you want to communicate to a host, to a PC, which is in your own broadcast domain, which is in your own VLAN segment, which is in your own IP address range. To allow communication, that you have to allow the layer 2 communication between them. So in this particular scenario, what I want to do for the basic connectivity or test, always what we have to do basically basic ping test. So I say like, hey, I want to communicate to a host 10.1.2.2, and a lot of guys get amazed like, hey, every time when we try to plug or ping switch A to switch B, the first packet drops. And when I asked it to the teacher who is teaching me this particular topic, he told, brother, this is an ARP request. So that's why the first packet drops. But you don't know the complete picture, like why the packet is being dropped. What is an ARP request? What's the background behavior? So this thing you have to get understood. And this is what I'm going to show you. Here we're going to find the difference. So, normal process, I'm just taking a ping connectivity test to 10.1.2.2. And perfect. First packet drops. This is what we want to see. Similarly, I want to show you 10.1.2.3. Perfect. Here's a one packet drop. So now I'm going to demonstrate to you what's an ARP request. Ladies and gentlemen and my dear friends, if you are communicating a switch, host A wants to communicate to host 2, which is router 1, wants to communicate to router 2, which is being simulated. First of all, they are on the layer 2 network. They are not into a layer 3 network. They are on a layer 2 network. They are on a layer 2 Ethernet segment network. So, an Ethernet segment allows the communication on the basis of layer 2 MAC addresses. It does not know about these particular IP addresses and all that. So, my dear friends, when PC1 wants to communicate PC2, which means router 1 wants to communicate to router number 2, it will send an ARP request. An ARP request means it will basically create a it just basically send an ARP request to router number 2. Now what's an ARP request? The first thing is I'm going to show you the complete picture. First of all, router number 1 create a packet. The packet says, first of all, in the packet there will be host PC1, which is normally router 1, so host R1 IP address, okay. Then there will be host R2 IP address. Then there will be host R1 MAC, and then there will be host 2 R2 MAC. So first of all, when router 1 wants to communicate to router number 2, the traffic has to pass to that particular switch in between them. So the packet is built as like that. First of all, router number 1 creates an IP address format. There will be a host router 1 IP, router 2 IP, router 1 MAC address, and router 2 MAC address. So the good part of this story is router 1 knows like what's a MAC address for router number 2. So once he creates a packet, he will just put the IP address for himself. He will create the IP address of host 2 10.1.2.2, and then basically its own MAC address. Now how you can get the MAC address? You go to router number 1 and you can just get it, show interface fast Ethernet 0x0 include BIA. So this is basically the MAC address for this particular thing. So I can out here the MAC address. It's not coming here. It's a MAC address for host A. Now the first part of this story is like, now router 1 does not know about what's the MAC address for router number 2. So what he's gonna do, he's gonna just basically send a broadcast like ffff.ffff.ffff. Okay, so it is just gonna send a broadcast to main. Then basically traffic comes to router number 4. Traffic comes to router number 4. Now router number 4, which is basically a switch, it does not know about these particular IP addresses. It can only allow communication on the basis of MAC address table. So in the meanwhile, this switch number, router number 4, which is basically our switch, it's gonna build the basic MAC address table. It's gonna say, it's gonna be like that. It says like for VLAN 123, I have learned that for my fast Ethernet 1x1, the IP address is basically, for example, when router number 1 sends a request to router number 2, okay, send the router number 4, which is basically a switch, stores that particular MAC address, source MAC address that you learned on that particular address. So he's gonna say like ca00.2230.0000. But now router number 4 gets the host or the destination address is all left, like it's broadcast. So router number 4 gonna get the packet and it basically send the broadcast to router number 2 and router number 3. When router number 2 gonna get that particular request, this is an ARP request behavior. He's gonna say like, hey, router number 4 gonna send that request to R2 as well as to R3, but only router number 2 gonna reply because that particular IP address belongs to router number 2. It does not belong to router number 3. So then router number 2 gonna build another frame. Same frame, there will be 10.1.2.2. There will be his destination IP address 10.1.2.1. Okay, now its source address, which will be if I go to router number 2, if I want to see like, hey, what's show interface fast number 0x0 include BIA, its particular MAC address. So he's gonna store like, hey, there is my particular MAC address. It's basically router 2 MAC address, because now the traffic is going from router number 2 to router number 1, and he's going to store the basically R1 MAC address, which will be ca002230.0000. So if you want, I can write on the top specifically for you guys. So this is basically R2 IP, R1 IP, and then we have basically R2 MAC. This is the MAC request, ARP request, which was sent to by router number 1, and R1. And similarly, router number 2 gonna send this particular packet to R4. In the meanwhile, R4, which is the switch, it's gonna store like for VLAN 123, the source MAC address. It's storing on the basis of source MAC address that I've learned on this particular port is ca01.2230.000. Now router number 1 has got the ARP request. Now if I go to router number 1, which is host A, ARP table, and see show ARP, we can see like router number 1 stored the ARP request. He's telling for my IP address, this is my IP address, and if I want to allow communication to host number 2, its IP address will be ca01.2230.000. Okay, now router number 1 has also built up their ARP table, switch, which also built up their MAC address table, and router number 2 also knows about R1. Now the next time when router number 1 gonna create a packet, it's gonna say like, I want to communicate 10.1.2.1, I want to send my traffic to 10.2.2. My source address is ca002230.000, and I want to communicate to ca01.2230.000. Now once the traffic comes to router number 4, Route number 4 gonna make a look in routing table, like the traffic is coming from this particular source, which is route number 1, and he wants to communicate to CA01G2300000. Once you look that, hey, this traffic it's going towards router number 2 on my interface faster than 1 by 2. Similar communication gonna happen between route number 1 and route number 3, or route number 3 to route number 1, and route number 3 and route number 2. So friends, today we discussed about the basic understanding of layer 2 ARP and MAC addressing. So a network, if you want to communicate in your own broadcast domain, your own VLAN segment, you have to work on the layer 2 network. Thank you so much for watching this particular video, and kindly subscribe to my channel to know more basic understanding videos and to higher level videos. Thank you all my friends. God bless you all.